Hello friends and welcome. Last time I talked about how various forces and properties of matter were just simply an effect of matter just existing. I talked about the magnetic effect, diamagnetism, waves, and inertia. This time I'm going to talk about what time is and what space is, and how it is simply matter just existing, just matter. So here's a marble, and it's just sitting there. Nothing special about this marble. This marble here, it's a piece of the present time. It's a piece of space. And remember how last time I talked about how even space is not empty, but that it's full of matter. Well, you can call this matter, or you can call this you can call it substance if you want, but it's just there. It's just stuff. It's just dirt, it's just a rock, or whatever you want to call it. It's just there. And that's what it's doing right now. It's just sitting there, not doing anything. And while it's there, you could say it's taking up space, but it is space. And it's this much space. It's also time because it's a piece of the present. Why, if this wasn't a piece of the present, then it would be found to be at no time. But here it is, existing in the present. And if it wasn't space, then it would be found at no place. But here it is. Among all the other places, here it is, existing as space. I know people say that matter exists in space and matter exists in time, but that's not the case. Matter exists as space and matter exists as time. How is there another way that we can show that? Well, we could displace it in a line using another piece of matter. We could displace this thing. And if we did that, if we displaced it linearly like that, it would take some time. Why? Because again, matter is time. But when we displace matter in a line like this, see how we're displacing it in a line? Then it takes linear time to do that. Why? Because this is a fully existing piece of the present, as some people say. This is, well, time. So if we displace time in a line, or a piece of the present in a line, we will get time. We can measure time out. We can measure linear time. Compare that to other linear time. So, and why? Well, if there's stuff in front of it here, and there is, and there's stuff behind it here pushing it, then we're displacing matter. Therefore, we're displacing time. If you displace time in a line, you will get linear time, that is linear time out. And you can compare that to another interaction, say over here. And say you have two marbles here, and say you have two marbles over here. And as long as you have the same amount of matter here as you do the same amount of matter here, resisting the change, the same resistance of the change, same down here, same stuff resisting the change, the same push here, the same push here, the same matter stopping it here, the same matter stopping here, and the stuff that's being displaced. As long as the displacement is the same, the interaction, the linear time you get that you're measuring is the same, which is why you can synchronize one clock on one part of the Earth and another clock on another part of the Earth. Linear time is, if you're synchronizing watches, it's not like the watches are actually connected. No, it's just that the interaction of this watch over here is the same as the interaction of this watch over here. What they're measuring is matter displacement inside the watch. So, for example, if you were looking at an analog watch, then what you've got is a pendulum swing. A gear pendulum swing, usually in an analog watch that swings the matter back and forth, usually balanced on a crystal. With a digital watch, digital clock, what you're doing in there is you have electrons swinging back this way and then back that way, back this way and back that way, inside a crystal which bends this way and that way, this way and that way. And so again, it's just the moving of matter. It's just electrons moving in that case. And with the same thing with an hourglass. If you have an hourglass, you have individual grains of sand seeping past a very narrow point. And as the sand passes, that is, the matter moves, just like in all clocks. The motion of the matter, displacing of the matter, is how you measure time. That is linear time. Fully existing time, though, that lasts forever. Matter is neither created nor destroyed. It lasts forever. You can break it down into very, very small pieces, but you can't really destroy matter, nor can you turn it into any kind of magical energy. Matter is. Now, here's a tape measure, and whatever you can say about time relating to time, you can also say about space relating to space. Here's a tape measure, and you can measure across the matter using other matter in a line. Now, if I measure this space linearly, then I am measuring this matter in a line, and I will get a linear measure out. Now, this is a spatial measure. Instead of a measure of the matter's time, I'm measuring the matter's space. There's space to matter, just as there's space to this tape measure. Now, again, just like time, linear time does not exist apart from the matter, just as linear space does not exist apart from the matter. Without this tape measure, I would have no comparative tool to measure this matter against this matter to find out that they were indeed the same amount of space. But since I have matter to measure it out linearly, I can measure across it in a line, and I can know that this compares to this. Now, people talk about dimensions, but how many dimensions are there? I mean, they say there's height, and there's width, and there's depth, but that would be like putting everything in a box. Like if you only had height, width, and depth, then you've gotten 1, 2, the 3 of the measures, or you could double it and say you went this way and this way, this way and this way. So you could say you had 6 of the measures. But in reality, the things aren't all boxes, and they also expand this way and this way, and this way and this way in every single possible way, all the way out in every direction. Now, of course, in dimensions, they say, well, if you've covered this direction and this direction, then you've got everything in between magically somehow. But let's think about it logically. We're talking about directions here. So dimensions is not really an accurate way of describing matter, because matter's not always a box. I mean, and even if it was, how can you figure that if you've measured between here and here, that you've got every single possible point between? It's better not to think in dimension-wise, as it's better to say this is a fully existing, in all directions infinitely, in all directions, every single point you can possibly think of. This is a fully existing piece of matter. It exists fully, and I think that's a better way of looking at it. Now, because this is a piece of time, that is a piece of the present, the forever present, as I've heard people say, then we can't really say that we can go back in time or forward in time, because if matter was displaced like this, the only way you could bring it back to a place where it was to displace it in the exact opposite manner. For example, if you had a cup full of water and you poured it out into another cup, why, the only way to make time reverse, as you could say, would be to pour it back in and reverse all the displacement. But that's not really going back in time, is it? It's linear time was thought to be the only kind of time that existed, because people didn't know that matter was time necessarily. But if you understand that matter is time, and that linear time comes from linear matter displacement, or rather it is a measure of the fully existing time that's here, that matter displacement is a measure of this fully existing time, then you realize that linear time doesn't actually exist, but rather is only a measure of fully existing time. So because linear time, you could say, does not exist, then there's not really a way to travel back and forth in it. So this should reveal to people that time travel is not possible. Okay, remember how I was saying that force, it does not exist except for that matter is always falling into the hole. So if matter's falling into a hole, then that's acceleration. If matter is bumping up against other matter, that's what causes deceleration. In fact, this is the only thing that causes acceleration, is if matter falls into a hole. And the only thing that causes deceleration is matter bumping up against other matter. Why? Because matter is time. So if it's decelerating, it's bumping up against time and displacing it. So the decelerating of an object is caused by the displacing of time. That is, the linear displacing of time, the linear displacing of matter, will cause deceleration. Whereas acceleration, as I just said, is when matter is being sucked into a hole. Well, of course, it's not actually being sucked into the hole as much as it is being pushed into the hole by the entire matter universe. So, yeah, that's the proper way of looking at it. What's interesting about acceleration and deceleration is that every action could be seen as an inaction. that the entire grand unified theory it does all boil down to matter simply being, simply existing, because even action, even motion, could be considered not to exist anywhere. And I'll show you why. Because in space that was thought to be empty, you run into if you throw an object like that, it will never decelerate. Why? Because in space you're running into just as many holes as you are matter. So every time it runs into a hole, it accelerates. Every time it runs into matter, it decelerates. But it's running into just as much matter as it is holes. And so you throw a marble into space, and it'll just keep going and going and going at the same speed. Unless it enters what people call a gravitational field, or a gravitational force. Remember how I talked about gravity last time and showed that around larger objects there are larger holes. So you have the matter that's been sucked in densely around the object, but you have larger holes around the matter because of the large surfaces that hold out the larger holes. So what you've got is, if this is traveling through space at a constant rate, but then here's the Earth over here, then you've got an interesting happening. So this marble is traveling towards the Earth. Here's the Earth. And it's coming, it starts feeling the gravitational pull, but it's not gravity, is it? Because gravity is not a force either. It's starting to run into more and more holes, and the more and more holes starts accelerating it as it runs to more and more and more and more holes until it crashes into the surface, in which case it's bumping up against the matter, and it decelerates. So there you have an interesting effect of gravity. Why is every action an inaction? Why could everything be considering not to ever happen? That is, nothing happens other than this thing simply existing. This is a piece of the present. This is a piece of volume, of like you could say three-dimensional space, but it's just, it's volume. It's fully existing space, fully existing time. So if you had a completely empty hole here, a hole that had nothing in it, it's theoretical because it's not, really, it's not really possible to have an empty hole, but if you have a hole here, then it will take absolutely no time and no space for this to take over the hole. Why? Because in the hole there is no space and no time. So if this falls into the hole, if it takes it over, if it's sucked in, then here is something taking over nothing. And when something takes over nothing, then what happened was nothing. This nothing happened to this something. And because of that, you have nothing happening. You have absolutely nothing happening. And that is the premise of all motion in the entire universe, whether you're talking about gravity or electric force, repelling, attracting, every kind of motion, nothing is happening to the something, other than the something simply exists. It's there to be pushed, and It's there to just exist. Now, during deceleration, it's slowing stuff down. When it's slowing stuff down, you could say something is happening. But you can't really say something is happening because it's decelerating. Therefore, the lack of something is beginning to happen. Therefore, the nothing is happening. Whereas with matter displacement, you can say, is still there's nothing happening. So, with matter, the action and the state of being are one thing. So the grand unified theory all boils down to matter simply existing as a piece of existence among all the other pieces of existence throughout the entire universe, an endless sea of matter. I might also mention that Einstein also believed that the change of space and time had to do with the force of gravity, and he was right. He just didn't know that space, time, and matter were all one thing. But yeah, the grand unified theory in a single marble, there's every force, every property of matter can be explained simply by